So section 9.2, we're going to go over rational exponents, things like this, 81 to the 1/4 power. In fact, for fun, we'll put a little negative out in front as well. But if you did the video, hopefully you saw a little trick that I had in converting something from rational exponents to a radical. What was that little trick? Say again?
The boot method?
Excellent. The boot method, right. So you imagine a little boot next to this denominator. It kicks that 4 over, and then the 1 drops down. Now, the important question is, what's going to go underneath the radical? I got a 4 here. I got an 81. Am I going to put the negative under the radical or not?
No.
It'll be on the outside?
It's going to be on the outside. So if I wanted the 81 to be negative, to have that on the inside, I had to write it like this. Negative 81 to the 1/4 power, like that. And that would put it on the inside. Here, I've got the 4th root of 81 to the 1st power. You can ignore the to the 1st power, it's just 81. So the negative 4 of that, or negative of the 4th root of that, is going to be negative 3. Now, it makes a big difference if we have parentheses or not. Because here I got negative 3. Can anyone tell me what's going to happen with this one?
It'll be positive.
Yeah. Somebody's been watching my videos. I called it NARN, which is not a real number. Now, I'll give you a little heads up. NARN has not caught on with the wider math world. I don't know why. It's really, really cool, but it hasn't. So on WebAssign, it's probably just going to be saying not real or something like that is what you're going to have to answer. Let's do some more here. So the next one I want to work on is 36 to the 3/2, because I want to practice doing these things on a calculator. Now, if you don't have a regular graphing calculator or scientific calculator, like I mentioned earlier, you can use Desmos for that. So go to desmos.com/scientific, and you can do stuff like the 4th root of 81. So other than the square root, if you need a 3rd root, 4th root, or whatever, click this one, type in the 4 up here for the power of your radical, or its index is sometimes called. And then 81, 4th root of 81 is 3. Beautiful. Let's keep going with one down here. And that'd be 36 over 49 to the 3/2 power. We're actually going to look at that a variety of ways. So the first way I want to look at it would be to write it using radicals. So we'll do my little boot here, and I should probably write that more up and down next time. But the 2 is going to come over and the 3 is going to drop down. So I'll get the square root of 36 over 49 to the 3rd power. And I'm going to offer you 2 different ways to do this. One way to do this is to start by ignoring the cube and doing the square root first. So that's something I think we can do in our heads without even resorting to our calculators. So it's going to be the square root of 36. Someone help me out with that. What's the square root of 36? 6. What's the square root of 49?
7.
So 6 over 7, but that cube is still there, right?
Yep.
Now, maybe you haven't been working with this stuff long enough, but I certainly have. I've got 6 cubed as memorized as 216. And 7 cubed is 343. So that's one way you could do it. We'll call that maybe method A. So we'll put A here. There's another way you could do this, and we'll see what you like better. The other way is you could start by cubing this and then take the square root. So I won't lie to you. I gotta do these things on a calculator. 36 cubed. So that'd be raised to the third power, like that. 46,656. And then 49 cubed should be close to 120,000, say, I don't know, 117-ish, 118,000. There you go. So 117,649. Looking okay there. But now I want to take the square root of each of these, and that's going to be kind of a pain, but all you have to do is type it in. And guess what? You get 216 over 343 when you take the square root of the numerator, square root of the denominator. One of the questions in your homework is going to ask you to do it both ways. You're going to get the same number both times, but which way is easier? A or B?
A.
Oh, I definitely like working with A, because by doing the root first, you're giving yourself smaller numbers, and then some you can do by your head, some you can't, but either way, it's still smaller numbers. So I like A better for sure. Now, the thing is, on a test, on WebAssign, you're not going to have to do this by hand. I don't expect it, nor do I really want it. So let's take a look at it on the graphing calculator. Now, this is assuming that you have a graphing calculator. I'm just going to type it in exactly the way the problem is presented. Left parenthesis, 36 divided by 49. Right parenthesis, I want to raise that to the 3/2 power. So 3 divided by 2. And when I do this, I'm going to get a really ugly looking number. But there's a trick. And that trick is to hit the math key and then press enter twice, because that's going to turn your answer into a fraction, if possible. There you go. 216 over 343. And that's it. So that's what you have to be able to do. Now, if you don't have a graphing calculator, if you're stuck using a scientific calculator or that little thing I showed you on Desmos, then what you're going to have to do is maybe do both of those things, or just have to something to the 3/2 power twice, once for the numerator and once for the denominator. So basically, you're going to say, all right, well, that's 36 to the 3/2 power over 49 to the 3/2 power, and then do them individually. And let me just show you one of these on like a graphing calculator. Actually, I'll do it here first. 36. The raised key is going to be this one. So raised to the 3 divided by 2 power. And if you look all the way to the right, I get 216. There is something I want to mention for those of you using an older TI-83 calculator, or maybe an 84 with an older operating system. If I did 36, actually, no, I got to do it this way. There. So let me clear all this stuff here. If I did parentheses 36 divided by 49 to the 3/2 power, if when you hit this key up here, and you can see it in red, if it actually shows you this little caret, you can't just get away with 3 divided by 2. It's not going to give you what you think. When I do my answer to fraction stuff, yeah, it's just a big mess. So what went wrong is that when you do this, you need parentheses around that exponent, because what it's doing is it's cubing the result and then dividing that result by 2. That's not what you want. So let's put in some parentheses here and here. So if you got an older calculator, you can still do this stuff. You just have to be a little bit more careful than somebody with the up-to-date calculators. All right, there's more tricks that I can show you, but I want to work on converting these things back and forth between rational exponents and fractions. And so the next example that I'm dealing with, or going to deal with, is going to take you back to stuff that we did in section 9.1. So let's take a look at x cubed raised to the 1/3 power. Help if I get that on the screen. Now, like a lot of these things, I'm going to imagine a little boot here and turn this into a radical. So this is going to be the cube root of x cubed. Technically, there's still a first power out here. But when I raise something to a first power, that's not really going to change anything. So I'll just write it as cube root of x cubed. What is the cube root of x cubed?
X.
Just
X.
x. All right. Let's try that one again. See if you can get this one right. Square root of x squared to the 1/2 power. Same kind of game here. 2 comes over, the 1 drops down. I get the square root of x squared to the first power. I'll ignore that 1 outside the parentheses. What do I get here?
X with an absolute value.
Oh, well done. X with the absolute value. I thought I was going to catch you guys on that. You proved me wrong. Well done. So, yeah, you get the absolute value of x here. And, oh, wow. Now, the reason you get the absolute value is because these two match and they're even. Up here, they match, but they were odd. You don't have to worry about it if it's an odd root. It's only when you have these even roots that you even have to think about the absolute value. Now, there's another one in our homework that looks like this. X plus 3 to the 8th power raised to the 1/8. Now, it looks like you should just be able to multiply these exponents. 1/3 times 3 gives me x to the first power, 1/2 times 2. But we saw here that, no, we can't quite get away with that always. The same thing's going to happen here. Can anyone figure out what this one's going to look like?
Isn't it just
Go ahead. We'll end up with 8 coming over, the 1 dropping down. So technically, there's still a 1 outside here. But I'll ignore the 1, and I just want to look at the 8th root of x plus 3 to the 8th power. What's that going to be?
Absolute value of x plus 3.
All right. Let me put down 2 choices, x plus 3 or absolute value of x plus 3.
Absolute value.
Absolute value.
Absolute value. Winner, winner, chinner, as they say at the craps table in Vegas. Yes, definitely need the absolute value because these things match and they're even. There's a couple more that want to do like that. We're okay here. Now Now, there's a
Hold
big
on,
part of me that,
question.
yeah, please.
Okay, why do we have to do the absolute value?
That's a good question. It's because when you take the square root of something squared like this, you don't know if that value of x is positive or negative. But you are going to end up with a positive value here, regardless if you ended up with, or if you started out with a positive value or not. So for instance, if I had the square root, and my pen is dying here. If I had the square root of, say, -5 squared, well, let's start underneath the radical. What's -5 squared?
It's a positive 25.
It's a positive 25. And what's the square root of 25?
5.
5. So I started out with something negative and squared it, and then it was something positive, right?
Yeah.
So if I start out with something that I don't know, like y squared, and I take its square root, I've got a guarantee that this is positive. But if I just write a y, I don't know if that's positive or negative, right? Because y, you'll see it in the problems, it'll say y, or the variable is unrestricted. Variable is unrestricted. And what they mean by that is that it can be positive or negative. And if it can be negative, to make it positive, I'd have to take its absolute value. So that's why we need the absolute value.
So
Does that
to be
help out?
safe, do you recommend always doing the absolute value?
I do, but you got to be careful about the problem, because if it says the variable is unrestricted, you'll need it. But if it says the variable is positive, then if I gave you like the square root of b squared, you just write b, because b couldn't be negative because they're telling you that the variable is positive. They're saying, all right, it's positive. Basically what they're saying is you don't have to worry about that negative case, and you won't need the absolute value. So it kind of depends on the problem, and it's not something that I like. I kind of dread that part of this section when we go over it, when I teach it, but it's just the way math is, right? It's the way the numbers are, and there's no getting around it. So I try my best to be gentle with this, but there is a little bit of a difference. You're actually lucky that you're not seeing this in class. There'd probably be more problems on the test that reflect this difference and be more points that you could lose that way. But for us, we're doing this online. It'd be a couple problems that might involve this, but not as many.
Okay, thanks.
Thank you. Thank you. Okay, let's do a couple more here with this, and then I put you into some groups. So the moral is, with these like this, even though it's tempting to say, oh, well, 1/3 of 3, just these exponents multiply, they do, but you got to be careful about the absolute values. So I'm not sure I know how to suggest you work around that, other than maybe just writing it with radicals first. 2 more examples. 32x to the 10th raised to the 1/5. Well, let's get back to our little boot method, and we'll kick that 5 over, and we'll end up with the 5th root of 32x to the 10th raised to the 1st power. Do I need that 1 out there, or can I just get rid of this parenthesis and that exponent?
Yeah.
All right. By assent, I suppose we're saying that, okay, you know what? You don't need the 1 outside there. That's fine. Now, what's nice is that I'm multiplying these two together. So I can take a look at the fifth root of 32 and the fifth root of x to the 10th separately. I can do that with multiplication and division. I can't do it with addition and subtraction. I doubt that you've been working with higher roots long enough to know what the fifth root of 32 is. So find that on your calculator. And if you need some help, let me show you. Let me show you on a graphing calculator. So again, I want to clear out some stuff here.
Yes.
You're going to go to the math menu, and the fifth option down allows you to take, whatever root. So I want to put there a 5 up there. Oh, you know what? I know I forgot to change my mode back to the regular classic mode, or the regular math print mode. All right. Because looking at that, I was like, wait a minute, this isn't what I expected. So let me try this again. Math, and then the fifth option down. It's going to ask you, well, what root are you dealing with? Well, the fifth root. Then use the right arrow to get over to the radicand. That is that part of problem that's underneath the radical. Bam, you got a 2. And you can see the keys that I pressed to get that underneath here. So there's my key history. So the first part is a 2. The second part, the fifth root of x to the 10th.
X
No,
to the 5th.
Is it x to the 5th?
X squared.
Oh, x squared.
Tell you what, this is where you can use the old football play, the reverse boot. Yay. So the 10 comes up, the 5 comes underneath. And this is what I said when we were dealing with higher power roots earlier, not in this lecture, but in 9.1, is that you take this exponent and divide it by the power of the radical. 10 divided by 5 gives you 2. Because this is an odd root, you don't have to worry about absolute values at all. And even if you did, out of safety, put an absolute value around this, hopefully you'd look at this and say, oh, wait a minute. X squared, when I square something, I'm always going to get a positive number or 0. And either way, I wouldn't need the absolute value. So this would be the correct final answer on that one. It's 2x squared. Yay. Last one like this. -9 p to the 8th power raised to the 1. Let's do our little boot trick again. See if you can't race ahead of me and write down what this would look like in a radical. Anyone want to share with me what I should write underneath here? What power is going to be out here?
8.
An 8.
8.
8. Well done. Thank you. And what should I write underneath the radical, the radicand? What should it be?
9.
-9.
Beside the parentheses
-9
would be
to the 8th.
-9 p to the 8th.
Thank you. -9 p to the 8th. Now, I skipped this part where I wrote it to the first power. I just kind of went from here over to here. So, okay. And from there, I can break this up a little bit as the 8th root of -9 and the 8th root of p to the 8th. Okay. Any thoughts on this one?
Wouldn't it be 9?
Well done. Right here, you've got the even root of a negative number. And we just don't have a real number for that. So it's not a real number. Real number. And I forget exactly what WebAssign has to say about that. You know, I think it's just not a real number, or, you know, not real solution, something like that. But yeah, you can't do anything with this with what we know now. So you're stuck. One final little reminder here. You can split things up when you're multiplying or dividing. We've seen that today. I did that earlier. With these radicals, you can split it up into a numerator and a denominator. That's fine. But it doesn't work with addition and subtraction. I like to remind people of that. So for instance, let me try and think of one real quick. Let's do the square root of 169 minus 25. What if I tried to break that up? Square root of 169 minus the square root of 25. Well, over here, I know I get 144. Here, that's 13 minus 5. 13 minus 5 is 8, but over here I get a 12. And so what that's showing you is you can't just distribute this radical and subtract the radicals. You have to work it as one whole term and simplify it there. So you can split things up with multiplication, like I did here and like I did here. You can split things up with division, but not addition and subtraction. Okay, so how are we looking on these? Pretty good? Let's get started on some homework. So I'll stop things here and put you into some groups.